Similar figures. So up until now we've been talking about congruent figures, which means that the size and the shape of the figures are exactly the same. Corresponding sides are equal to each other, corresponding angles are equal to each other. We're going to start talking about figures that are not congruent. They are similar, and similar is very specific when we start talking about geometry. So similar figures, these are figures that have the same shape but do not necessarily have the same size, are called similar figures. So they can be the same size, they still count as similar. However, they don't have to be the same size. So if you imagine that you put one of the figures on a copy machine and enlarged it or reduced it, they are the same shape, but they're not necessarily the same size. In this particular diagram we have here, triangle ABC is similar to triangle DEF. And you'll notice that we have some of this notation that we've looked at before in our shapes. I have this one kind of arc here, representing this one arc here. So these two angles have the same measure. I have this two arcs here, an angle C and F. Those two angles have the same measure. And A and D have the same set of arcs. So they are equal to each other. So we know our corresponding angles, and then because of that, we know our corresponding sides. So two figures are similar when corresponding side lengths are proportional. So they're going to have proportional side lengths, not necessarily congruent side lengths. And corresponding angles are congruent. So we've already checked with these that the corresponding angles are congruent. Let's take a look at their side lengths. So their side lengths we can set up as ratios. Remember, a ratio is a numerator and denominator. It looks a lot like a fraction. It is a fraction. And we're going to put a corresponding side over its corresponding side. So AB and DE. So AB and DE are corresponding. Remember, we talked about kind of the order of the letters we want to pay attention to. I'm going from this angle that has 3 arcs to this angle that has 1. I'm going from the angle that has 3 arcs to the angle that has 1. So these two sides are corresponding, which means their side lengths should be proportional to other corresponding sides. If I look at BC, that should be the it should be proportional as AB to DE is compared to EF. So I should be able to set up my corresponding sides and have a true proportion. Our angles, these are congruent. This is the symbol that we use to show congruency. It looks like an equal sign with a little wavy sign over it on the top there. So an equal sign with one little wavy sign on the top. That's our congruent as far as geometry. And then we can say that the figures, triangle ABC, one little wavy sign means similar. So they're not congruent to each other. They're not exactly the same, but they are proportional to each other. So this is our congruent. This is our, similar symbol. This is similar. This is congruent. Okay? All right, let's use our similar figures to find some missing pieces here. Which parallelogram is similar to parallelogram A? So you should have these 3 pictures in front of you. We've got parallelogram A, B, and C. And I've gone ahead and labeled my vertices to kind of help me look at the corresponding sides. So I've called my corners in parallelogram A, B, C, and D. I've called my vertices in parallelogram B, W, X, Y, and Z. And I've called my corners, my vertices in parallelogram C, K, L, M, N. So I can talk about the different sides and the different vertices in each of these shapes and compare them to each other. So I should see that I have corresponding angles in each of my shapes. So I'm going to talk about parallelogram A and parallelogram B first, and we're going to see if they are similar to each other. So they need to have congruent angles. So I've got A and W, they're congruent. B and X, they're congruent. C and Y, they're congruent. And D and Z, they're congruent. So it passes the first test, that corresponding angles are congruent. So far, so good. Let's take a look at our corresponding sides. They should have a proportional, the same ratio. They should be proportional to each other. So if I look at side BC and compare it to side XY, so here's BC, here's XY, they're corresponding. I come up with a ratio 8/4, which when I simplify is equal to 2/1. Let's look at another pair of corresponding sides. I'll take CD and compare it to YZ. I get 12/6. 12/6. When I simplify that, I get 2/1. So because I'm comparing corresponding sides and I keep coming up with the same ratio, these parallelograms A and B are similar. We have congruent angles, congruent vertices, and proportional sides. So those two are similar. Let's see if parallelogram A is similar to parallelogram C. So I'm going to compare those two. So again, I'm going to look at my angles, and A and K are congruent, B and L are congruent, C and M are congruent, D and N are congruent. So that checks off. I have corresponding angles are congruent. Let's check to see if our sides are proportional. I'm going to try BC and LM, and I get 8 over 6. When I simplify that, that's 4/3. And then I'm going to try CD and NM, and I get 12 and 12, which simplifies to 1. So I don't have two ratios that are the same as each other, which is what I should get. So because these are not the same, these are not similar. I can't take this one, put it on a copy machine, and change its side, reduce or enlarge it, and get this parallelogram here. So they're not similar. So parallelograms A and C are not similar. How else can we use our similar figures? We can use that, if we know they're similar, we can use that fact to find out missing measures. So the triangles are similar. They've already told us that. They would like us to find x. So here's our missing x here. We're going to set up a proportion. So the first thing to do is write a proportion. And we're going to put corresponding sides with corresponding sides. So I've chosen to take 8 and 4 and set those up. And I'm going to use x and 6. So notice I put the tall side over the short side in my first proportion, in my first ratio, and I put the tall side over the short side in my second proportion here. Notice the numerators here are corresponding side lengths, and the denominators here are corresponding side lengths. So I should be able to match things up in all 4 directions. From my proportion, I set up an equation. Back to that algebra. Here it comes. I set up a proportion. I use my proportion and cross products to write an equation. So I come up with 4 times x equals 8 times 6. 8 times 6 is 48. I divide both sides by 4 to isolate that x, get the x by itself. And I come up with x equals 12. Our label here was centimeters. So I find that side x here is 12 centimeters, which is a reasonable estimate. If my base here is larger than my first triangle, my height should also be larger than my first triangle too. Similar figures.